I'm speaking to you from the future. Here in 2060, every September 22nd is a holiday throughout the entire galaxy. Since we remember that same day, but 40 years ago, on September 22nd, 2020, a Californian company explained to the world how it was going to change energy and transportation forever. We also laugh in amazement when we remember that the ladies and gentlemen of that time, that day, you didn't understand anything, since the press barely covered it, and also the shares of that corporation fell 10%. If you keep putting up with me for decades, you'll see the rest of this video. But today I wonder how those men and women of 2020 didn't come to understand that Tesla was about to disrupt the energy world by cutting the price of batteries in half, doubling its range, and reducing the investment per gigawatt hour by 69%. In other words, this last point that has been talked about much less is crucial. With the advances of the battery day, the investment of the new cell factories is over 2/3 cheaper. And in this investment, the factor that contributes the most is the battery factory itself. In it, the process to make a new cell begins with the manufacture of the electrodes, continues with the winding to roll them, then with the assembly, and ends with the formation. This last point, the formation, represents 25% of the investment in a normal factory. Well, Tesla has managed with all its breakthroughs in this state to reduce investment by 86% and reduce its footprint by 75%. How long do you think Drew and Elon talked about this dramatic advance in one of the most important processes in the manufacture of the new batteries? 47. 47 minutes is not that bad. No, Alejandro, no. I mean 47 seconds. In other words, we don't know anything about how Tesla achieves these disruptions. Or rather, should I say, we didn't know anything. Because on June 22nd, 2021, a Tesla patent was made public that explains in detail the incredible improvements that allow to achieve these reductions in investment and space. It has taken me such a long time to understand this patent, but I finally succeeded. By the way, since I'm not an expert on this subject, if I've made a mistake, I'm sorry, and please, if you detect it, I would be grateful if you could comment on it. In this video, we're going to see in detail the formation pattern of the new Tesla 4680 cells, a revolution in the manufacture of the batteries of the future. Hi, this is Alejandro, and welcome to the best moment in history. And now you could help me also to have a big breakthrough in the algorithms of YouTube if you liked it right now. Thank you very much.
Is about a 75% reduction in the investment per kilowatt hour or gigawatt hour. It's just basically 4 times better than the current state of the art to the best of our knowledge. And I think there's probably room to improve even beyond that.
Definitely.
Definitely, yeah. So we're able to, from a volume standpoint, actually get what in a smaller form factor than Giga Nevada, we were able to get many times the cell output. So you can see, like, basically, we can get a terawatt hour in less space than it took to make a gigawatt hour. 150 gigawatt hours. So this is pretty profound. It's like I would actually not have thought this was possible several years ago. That we could actually get to terawatt hour scale in less space than what we currently envision for doing 150 gigawatt hours.
What Elon is referring here is that when the Nevada Gigafactory was built with traditional technologies, it was expected that they could reach 150 gigawatt hours. But now, with the new 4680 cells and their new production processes, in a smaller factory, they can manufacture almost 7 times more. And this is because Tesla, to design its new battery factory, thought outside the box and among other things was not inspired by the current battery industry, relatively young, but by industries that had been optimizing for many decades and with a huge production volume. That is, newspapers and bottles. However, the speed that Tesla gained in the first steps of manufacturing its batteries was of little use when they arrived to the formation, since for this step the cells have to be stored for about 24 hours. But what is this formation? Well, it is one of the last steps in creating a battery cell. When first manufacturing a battery, it is not charged, so the formation is a controlled charge and discharge cycle that activates it. This process also serves for two more functions: detect those cells that do not meet a minimum quality standard to be used in a battery pack, and the creation of the SEI, solid electrolyte interface, which is no more than a protective layer on the anode. So how does Tesla improve such an important process? In the patent that I leave you in the description, there are many advances that I recommend you to read carefully, but I have grouped them in three large fields. First one, less material. In the same way that the first Model S had 3 kilometers of cables, then only a few years later it came down to 1.3 kilometers in the Model 3, and there's already a patent to reduce it to 100 meters, Tesla is obsessed with reducing materials as much as possible. In the case of formation, it is also cables that can have up to 4 per cell, which is tremendously inefficient. You just have to look at the figure 10 of the patent, in which it's clearly seen how the drawing on the left, which is a diagram of the conventional system, needs a much more extensive wiring because they use a parallel system, while Tesla's is a series 1. But this savings is not reserved to the cables, as explained by the patent itself. On the left is a conventional cell-forming system, which requires a separate power supply unit for each group of cells. The present inventive system, as shown on the right, only needs one power supply unit for a number of clamshell structures, each of which can accommodate 256 cells. And this means that with these material savings, we can move on to the second major field, which is less space. Tesla manages to compact its systems, avoiding redundant procedures as the patent states. Figure 9 shows a conventional power supply chain. In contrast, as shown in the bottom of Figure 9, embodiments of the present invention utilize an AC-DC conversion unit to directly convert a 277-volt AC power to a 50-volt DC power. This 50-volt DC power is then shared among the clamshell structures housed in a rack. Or if we translate it to human language, with traditional systems, a substation is needed for every 256 cells, while with Tesla's, a substation serves 1280 cells and also saves several steps. But this productivity improvement due to a reduction in space is not new. Elon Musk has been obsessed about it for years, but lately, this obsession is starting to pay off.
The rear body castings for Model Y allowed us to reduce the body shop by 30%.
Yeah.
So there's roughly 1,000 robots on the Model 3 body line, which, by the way, is also not a figure of merit. You want fewer things, not more.
Yeah.
We got rid of 300 robots just with that rear body casting.
Yeah.
And then when we go to the front body casting, we're getting rid of another 300 robots.
Right.
However, it's not necessary to go to the chassis to detect these improvements. In the same manufacturer of the cells with their dry battery electrode technology, they have gone from this to this. So now I want you to pay attention. In this formation process, look at the difference in space between groups of cells. This is a conventional process for a production of BMW cells, and this is Tesla's system, much denser. But of course, in this desire to optimize space, if you have noticed, there is a huge waste, and it's the corridors that are needed for the operator to carry the cells. As I said at the beginning of this video, Tesla is not trying to optimize what the legacy industry is already doing, but is looking elsewhere for inspiration. And these corridors could not be any exception, as the patent explains. These shelves can be placed on tracks and be moved as needed like bookshelves in a library. That is, the shelves could be moved. But as Tesla explains shortly after, in the end they have opted for an even more disruptive solution, and that is that these shelves are static and there is a robotic arm that can act at ease. As you can see in this drawing of the plan of the formation room, it shows the cells and the rails of the robotic arms. But it's much better that we see it live. This same passion for optimization has led Tesla to want to save space in a very important system in this process. That's it, air conditioning. This installation takes a lot of space since the cells have to be at a certain temperature, and Tesla with its new production system has managed to reduce it to a minimum. But how? Well, with the third and final field of improvement, that is, more efficiency. The existing formation system uses air cooling to transfer heat generated by inefficient power usage, which in turn consumes power to remove heat, takes up space, and it's difficult to control without significant thermal gradients, which results in cell-to-cell variation. In short, a lot of heat is generated due to too much wiring, and also the air conditioning system is not very efficient. As we have seen in the first big field, Tesla dramatically reduces wiring. But what about its thermal control? Well, instead of cooling the whole room, they use an ingenious heat dissipation system. In this example, each of the 8-cell interface blocks in a clamshell structure can be coupled to a heat dissipation mechanism. This what means is that Tesla goes to the heat source, capturing it from the cell itself and redirecting this heat where it's most needed. This strategy of moving resources is also used with electricity. In the formation in which the cells have to be charged and uncharged in traditional system, this charge was lost. However, Tesla combines the discharge of some cells to the charge of others, and thus no electricity is lost. Therefore, Tesla has reinvented this fundamental stage in the manufacture of its new 4680 cells, and has done so thanks to two very powerful weapons. First, its holistic vision of the manufacturing. That is, Elon Musk's company thinks about the finished car, and from there they design and manufacture their parts and processes. While most companies think about the parts and processes that they can outsource and put them together to get the final vehicle. And the second reason is that to get each of these parts of these products, they have a very different approach than most companies.
Tesla is absurdly vertically integrated compared to other auto companies or basically almost any company. We have a massive amount of internal manufacturing technology that we build ourselves. We literally make the machine. In fact, we design. It's like, okay, what is the thing we want to make? Design the machine that will make that thing. Then we make the machine. This makes it quite difficult to copy Tesla, which we're not actually that opposed to people copying us, but it's quite difficult because you can't do catalog engineering. You can't just, I'll pick up the supplier catalog, I'll get one of this machine, one of that machine, bingo, I'm Tesla. You have to, there is no catalog. So we made the machine that made the machine that made the machine. We don't want to get carried away here, but, and quite frankly, we would like to outsource less. That would be great. Because then if we could take something that we're doing and outsource it, then we could take those people and we could have them do something else. Yeah, it's like we just make a crazy amount of machinery internally.
Lady, gentlemen, little gentleman, Tesla's disruption will be understood very soon. Before 2060, I hope. Hello, this is Alejandro, and welcome to the best moment in history. Did you know anything about this battery formation process? And what is the Tesla manufacturing system that impresses you the most? You live in the best moment in history. Enjoy! If you have enjoyed this type of content, subscribe to this channel so you won't miss videos like this one. And I recommend you to watch this other video that I made just for you. Thank you very much from the heart.